Section 2.6, Solving equations and inequalities with absolute value. First of all, absolute value of 5 is 5, and absolute value of -5 is also 5. Why is that? Well, because of the definition of absolute value of a number. Absolute value of a number is defined to be the measure of distance from 0 to that number on a number line. So in other words, if I have x minus 0, which you don't see it here, so this represents the measure of distance from an unknown number from 0 on a number line. On the other hand, absolute value of x minus 3 is the measure of the distance from not 0 but 3 to that number x on a number line. So the starting point for this guy is positive 3 as opposed to 0. On the other hand, if I had positive 3, absolute value of x plus 3, the starting point here would be negative 3. In other words, this would be a distance from a number and negative 3 on a number line. Why is that? Because I can rewrite this as x minus 3. Because remember, the measure of distance is what? Absolute value of the difference between two numbers, not the sum. So the question is, how do you go about finding the absolute value of 5? Well, this is the same as absolute value of x minus 0 is equal to 5, correct? You just don't see the 0. But what does that mean? That means on a number line, you have to go what? 5 units to the right of the 0 and 5 units to the left of the 0. And then those would be your solutions. In other words, the answer or solution to this problem, which was we were asked to solve, is namely -5 and 5. So those are the two solutions. Notice when the number on the right side is positive, we always get two answers. Why? Because we can either go to the right side of the 0, 5 units or to the left side of the 0, 5 units. What about this guy? Well, this guy, the starting point is at 2, not 0, correct? So I got to go 5 units to the right side of the 2, which that takes me to 7, and 5 units to the left side of the positive 2, and that would take me to what? -3. So the solutions are -3 and 7. And notice they both check the equation. So the bottom line is, when you have an equation with absolute value in it, and the number on the right side is positive, you always get two answers. So let's do a few cases. So there are 3 cases. Well, case 1 is, what if you have equation as opposed to inequality? So you have to see an equation. And the number on the right side is a positive number. So what you do is, this would be your starting point. So what this says is absolute value of x minus a is equal to b. What that says is the difference between what? A number and a is b units. So what does that mean? That means from a, you go b units to the right and b units to the left from a. So that would be the same as what? Adding what? A to b on the right side of a and subtracting b from a on the left side. So that would be like the case where you have equation and the number on the right side is positive. But the question is, what if you have a plus sign between x and a, and b is still positive? So in that case, your starting point, remember, is -a, not positive. Why? Because the difference between two numbers on a number line is always defined as what? Absolute value of the difference between the numbers, not the sum. So in this case, you have to take negative a, add b to it, so you get one of your solution, and take negative a and subtract b from it, you get your second solution. So in this particular case, the solutions are a plus b, a minus b, whereas if you add plus, you get what? Minus a minus b, and minus a plus b. Do I have to memorize any of these? Absolutely not. I'll show you how this is done without going through all these general formulas. So let's start. So the question is solve. You know what solve is. Solve means find values of x. Notice I said values. In other words, I'm expecting two answers. So to say absolute value of x is equal to 7, so that means what? I have to go from 0, 7 units to the right or 7 units to the left on a number line. But instead of saying all that, this is basically what we do. We kind of, step 1, drop the bars. Okay, drop the bars, so you get x. Okay. Step 2 is what? Attach what? Plus and minus to the right side. Okay. Why is that? Because we can go 7 units to the right side of the 0 and 7 units to the left side of the 0 on a number line. Remember, the starting point here is 0, so I can either go 7 units to the left or 7 units to the right. In other words, this is absolute value of what? 7, and this is absolute value of negative 7, correct? So the bottom line is the solution, which I'm going to show it with a couple of braces, is negative 7 and plus 7. Sometimes for short, they just write this as plus or minus 7. So either way is okay. Or you could just say minus 7 and box your answer. So there's no problem writing it this way. Okay, so we pretty much got the steps, and that's basically what we will do for the remaining examples. So let's do the next one. So step 1, drop the bars. Step 2, attach plus or minus to the right side, right? Step 3 is what? Solve each of these individual equations. So either x minus 4 is equal to what? Positive 6, or x minus 4 is equal to negative 6. Notice I did not change the sign of what's inside the bars. The only sign which I changed was the sign of the number on the right side of the equation. So please be careful. Otherwise, the answer won't come up right. So I have two equations to solve for x. Obviously, that would result in two answers. So add 4 to each side of these two equations. You don't have to do it simultaneously. You can do it one at a time. So x is either 10 or x is equal to negative 2. So the solutions are 10 and negative 2. Once again, notice I have two answers. Okay, the next one is absolute value of 2x minus 3 equals 9. So what are the steps? Drop the bars, attach plus or minus to the right side, and now that results into two equations. Either 2x minus 3 is equal to positive 9, or 2x minus 3 is equal to negative 9. Remember, once again, we do not change the sign of what's inside the bars. The only sign which gets to be changed is the sign of the number on the right side. In other words, we attach plus or minus to 9, but we leave this minus sign alone. Excuse me. So I have to solve two equations one at a time. First, I add 3 to both sides of these two equations. So I get what? 2x is equal to 12, so x is equal to 6. Or 2x is equal to what? Negative 6, so x is equal to what? negative 3. So those are my solutions. Once again, two solutions when you have absolute value and a positive number on the right side. For this problem, we have one additional steps. And the very first step before step 1, let's call it, I don't know, step 0, is what? Is to isolate the absolute what? Value term first on what? One side of the equation, first. So what does that mean? That means before you attach plus or minus to the 9, get rid of the 5. In other words, subtract 5 from both sides first. Okay, so these guys cancel. So you get 3x, what? Absolute value of 3x minus 8 is equal to 4. Now that you isolated the what? Term with absolute value in it, the expression with absolute value around it, now you follow the steps. What is it? Drop the bars and what? Attach plus or minus to the right side, which this results in two separate equations. Either 3x minus 8 is equal to 4 or 3x minus 8 is equal to negative 4. Now solve for x. If you add 8 to each side of these two equations, okay, you end up with 3x is equal to 12, so x is equal to 4, or 3x is equal to, what is this, 4 is it? And then x is equal to 4/3, and that's basically my solution. So my solutions are 4 and 4/3. We all see it. So that's basically what results out of solving the first equation and the second equation for x. So as usual, we have what? Two solutions, provided the number on the right side is positive. Why do we have two solutions? Because we can either go, what, 9 units to the right side or 9 units to the left side of what? In this particular case, the magic number is 3/2, but let's not worry about that. All I can show you is this. Suppose this is your house. Suppose the owner of the house is what? 2x minus 3. He or she can walk what? 9 miles to the right side of the house and 9 miles to the left side of the house. So that's basically what this equation is all about. In other words, 2x minus 3 can be what? 9 units to the right side of the house, or 2x minus 3 can be what? 9 units to the left side of the house. In other words, the owner of the house can what? Walk or, ride his or her bike 9 miles to the, I don't know, east of the house and 9 miles to the west of the house. So that's why we get these two answers. All right. Sometimes you may have fractions in your what? In your equation, so don't panic. Make sure the absolute value expression is isolated. There is no plus or minus any number attached to it. So now the procedure is what? Drop the bars, attach plus or minus to the right side, correct? But this results in two separate equations. Either minus x minus 2 over 5 is equal to positive 1, or x minus 2 over 5 is equal to negative 1. Be careful on the test or homework. Sometimes students have the tendency to change the sign of what's inside the bars. So be careful. We do not change the signs of any number inside the bars, only the number which is on the opposite side of the equation. Okay, so give a denominator of 1 to 1, and now cross multiply, so you get what? X minus 2 is equal to 5, so x is equal to 7, or cross multiply, so you get what? X minus 2 is equal to negative 5, x is equal to what now? Negative 3. So those are my solutions. My solutions are 7 and negative 3. Once again, two solutions because of the absolute value. Case 2 is what if you have x absolute value of x minus 1 less than b as opposed to what? Equal. So this is less than, and this is less than or equal to b, correct? Well, in this case, what that means is what? The distance from A to the number on a number line has to be less than B many units. In other words, if you go, let's say, B units from A to the right and B units away, from A to the left, you are only supposed to be somewhere between these two dots. So instead of isolated numbers, now we're going to come up with inequalities. Do you see it? In other words, x has to be between a plus b and a minus b, as opposed to just two isolated number in case of the equation where x was either a plus b or a minus b. In this case, x is less than a plus b, but greater than a minus b. Remember, this is the smaller number, which goes always to the left, and this is the larger number, which always goes to the right side of the inequality. Okay, so how do we solve this? Let's say you were asked to solve absolute value of x is less than 1. By the way, that's like what? The distance between a number and 0 is less than 1. So what does that mean? That means if this is the house right here and x is the owner, he or she is allowed to walk 1 mile to the right side of the house, 1 mile to the left side of the house, and anywhere in between -1 and 1. So what that means is the following. So the solution of this inequality is x has to be between -1 and 1. Notice the final answer showed up in inequality form as opposed to equation. Do you see it? So what that means is the owner of the house is allowed to walk somewhere within 1 mile of the house in either directions. So that's what this is. X is greater than -1, but less than 1. So as far as the number line, so you kind of go, here's -1, here's +1. Notice there is no equal sign, so the dots are open. So you connect the dots. And that's pretty much the picture of the solution. Do you see it? So what are the steps then? Well, the steps are drop the bars. Okay, put two inequality sign, facing the left side. Put the positive of this guy on the right side and negative of that number on the left side. So there it is. The solution is x is somewhere between -4 and +4. Remember, the smaller number goes to the left. The larger number goes to the right. Larger number. So how does this guy look like on a number line? Well, here's -4, here's +4. Remember, we have an equal sign, so you get to draw the solid dots. But x is somewhere between these guys. Remember, the way you read this, you go x is greater than or equal to -4, but less than or equal to 4. So you need to connect the dots. Do you see it? So any value between -4 and 4, including -4 and 4, is the solution of this inequality. What about this guy? Well, remember the procedure is, or the steps are, drop the bars. Okay, put an inequality on the left and inequality on the right. but make sure the inequalities point to the left, both of them, right? Put the positive of this number on the right side and the negative of that number on the left side. So now you have a compound inequality. This reads x minus 3 is greater than -1 and less than or equal to +1. Remember, the idea is isolate x. So what you do is you add 3 to each side of this inequality. Okay, these guys cancel. So x is greater than or equal to 2, but less than or equal to what? 4. And that's the final answer. So this is the final answer. Do we all see it? All right. So that's basically the procedure for less than. Once again, sometimes you may have a number attached, or I should say subtracted or added to the expression with the absolute value. Before you follow the steps, make sure you get rid of that guy first. Okay, so that will be like step 0. First thing we do is put this guy on the other side, like so. Okay, so now the problem reads absolute value of 2x plus 3 is less than or equal to what? 15. Okay, now the procedure. What's the procedure? Drop the bars, put 2 inequalities, one on the left, one on the right. Make sure they both point to the left. Put the positive of this guy on the right side and negative of the same number on the left side. So now you have a compound inequality. Remember, we did this in a previous section. So the idea is to solve or isolate this inequality for x. So x has to be in the middle. Okay? Well, this reads 2x plus 3 is greater than or equal to -15, but less than or equal to +15. First thing I do is what? Subtract 3 from either sides. So I get 2x greater than or equal to -18, but less than or equal to 12. Then I divide both sides by 2. Remember, 2 is a positive number, so there is no need to switch the signs. And what do I get? I get x is greater than or equal to -9, but less than or equal to 6. There goes the solution. This is the solution, or this is my final what? Answer. Do you see it? Right? How does the graph of this guy look like? Well, here's a number line. Here's 0. Let's say this is 6. Let's say that's -9. Because I have equal signs, so I get what? To put 2 dots, solid dots. And x, notice, is trapped between these 2 numbers. What does that mean? The value of x can be anything between -1 and 6, including -1, -9, and 6. So you connect the dots. Finally, case 3 is what if you got absolute value of x minus a is greater than b, or absolute value of x minus a is greater than or equal to b. So in this case, your starting point, once again, is a in both cases. Okay, provided there is a minus here. If there was a plus here, then the starting point will be what? -a. So just like before, you add what? B, subtract b. But remember, this reads absolute value of x minus 1 is greater than b. That means the distance between a number, between a and a number, is more than b. So remember, greater means more than. So what does that mean? That means once you add b to a or subtract b from a, now you have to go what? Further away from these 2 dots. Okay. Contrary to the previous section where we case where we connect the dots, now we have to what? Draw arrows going opposite direction of each other. So in this particular case, we always end up with what? A gap between our solutions. Do you see it? So if you have an equal sign, what? The dots become what? Positive. So when they say absolute value of what? X is greater than 8. So remember, greater means more than 8. Okay. So what does that mean? That means on a number line here is 0. Because remember, I can write this as x minus 0 is greater than 8. So my starting point is 0. I'm supposed to go what? Above or more than 8 miles away from the house. So if this is 8 miles to the left, 8 miles to the right, I'm supposed to go above and beyond that. So I gotta go further than 8 miles to the right and further than 8 miles to the left side of the house. Remember, this is my house and X is the owner. So when it comes to solution, because we have a gap, so the solution, shows up in two separate what? Inequalities. Either X is what? Remember, when the arrow goes left is less than this number. Now we have to use the word or. X is when the arrow goes to the right, you have to use greater than sign. So notice the solution shows up in two separate pieces or inequalities connected by the word or. So either what? Values of or solution to this inequality is values of x greater than 8 or less than -8, but nothing in between, right? So that's basically how we write this. What are the steps now? Well, the steps are write x twice. Okay. This is greater than or equal to. Take what? Two inequality sign, one less than or equal and one greater than or equal, and make sure you connect these two solutions with the word or. For less than, so for less than sign, switch the sign here. So that would be like -10. For greater than sign or more than sign, okay, no need to change the sign. But here we do need to change the sign. You see it. So for less than, we change the sign. For greater than, we keep the sign the same, which is always positive. So what are you saying? I'm saying the solution is x is less than or equal to -10. Don't forget the word or. X is greater than or equal to 10. So the question is, how would I remember to use what? Or for my answers when it comes to solving these kind of problems in section 2.6. Remember, more, okay, or greater or more should remind you of the word or, like more or greater. So anytime you have absolute value with a greater than sign, you can bet your money the solution pops in two separate forms, and the connective word is or. In other words, this is like you driving your car on Freeway 91 or 405. It can't be both. It's either or. Do you see it? Okay, so with that in mind, so let's do a few problems and then we should be a-okay. Once again, these are the cases where I have greater than sign. So what do I do? The steps are as follows. Check this out. You write x plus 4 twice. Don't forget to connect these guys with the word or. Okay. One of these guys takes what? Less than sign. The other guy takes greater than sign. So two cases, less than sign, greater than sign, correct? Greater than sign. The one which is less takes what? Opposite of this number. So change the sign. Change the sign. The one with greater, what? Takes the number itself. There's no need to change the sign. It's +5, so +5 goes over here. So now you have two inequalities to solve for x. If you subtract 4 from each side, Okay, you would end up with the first one is x is less than -9. Don't forget the word or. X is greater than 1. And box your answer, final answer. So what does that mean? That means on a number line, if this is the house, and the owner of the house is x plus 4, I'm allowed to go, what? Above and beyond 5 miles on either direction. Do you see it? Not in between, but above and beyond 5 miles. So what does that mean? Because the arrow pointing to the left, so that means this owner of the house can go what? X plus 4 is less than -5, or the arrow goes to the right, you go x plus 4, the owner of the house is what? Greater than 5, and then what? Solve for x. So that's pretty much how you remember what to do when you have greater than sign with absolute value. Okay, same thing goes here. So you kind of write this, split this into two cases. Okay, one of these guys takes less than or equal because there was an equal sign. The other guy takes greater than or equal. And don't forget the magic word in between is or. Okay, for less than, we take the opposite of the sign. Don't forget to change the sign. Okay. And for greater than sign, we keep the sign the same, which is +7. Now you have two inequalities with the word or in between. Isolate what these inequalities for x. First, subtract 5 from each side. Okay, so you get 2x is less than or equal to -12. 2x greater than or equal to 2. Divide both sides by 2. Remember, when you divide both sides or multiply both sides of an inequality by positive number, you don't have to switch the sign. So either x is less than or equal to -6 or x is greater than or equal to 1. So there, those are my final answers. Final answers. Do you see it? So what just happened here? Well, once again, here is the house, right? Who's the owner of the house? 2x plus 5. He or she is supposed to what? Walk or ride his or her bike or drive his or her car, what? Above and beyond 7 miles. So 7 miles or more on this direction, 7 miles or more miles in this direction, further up. So cannot be in between. So this arrow is what? Pointing to the left, so it has to be less than or equal. Well, equal because the inequality started with equal sign. So you go 2x plus 5 is less than -7, or notice here the arrow points to the right, so you go 2x plus 5 greater than or equal to 7. So this guy is greater than 7, but this guy is less than or equal to -7. That's how you would remember. This case, the first thing you do is what? Add 8. So you get absolute value of 7x plus 3 greater than or equal to 13. Okay, split this into two cases, 7x plus 3. Don't forget the word or between. Okay, now either this is less than or equal to -13 or greater than or equal to +13. Remember, because of this. So now isolate for x by subtracting 3 from each side. Okay, so you would end up with what? 7x is less than or equal to -16. Okay, which means x is less than or equal to -16 over 7. Don't forget the word or. And 7x is greater than or equal to 10. Okay, so x is greater than or equal to 10 over 7. So the way you write this, you go x is less than or equal to -16 over 7. Don't forget the word or. X is greater than or equal to what? 10 over 7. Box the answer. Finally, we have what? Fraction. So don't panic. Once again, you kind of go, okay, x plus x over 2 plus 4 is less than or equal to negative 7, or x over 2 plus 4 is greater than or equal to positive 7. Okay, so subtract 4. Okay, because you're trying to isolate the inequalities for x. You get x over 2 is less than or equal to negative 11, or x over 2 is greater than or equal to what? Positive 3. Multiply both sides of equation inequality by 2. Okay, so you end up with x is less than or equal to negative 22. Don't forget the word or. X is greater than or equal to 6. Final answer. So there you have it. Okay. Finally, we have something called special cases. I mean, you don't have to worry about it. I'm just showing you just to have a complete notes. What if you got the equation and the number on the right side is negative and we have absolute value on the left side? Remember, absolute value of a number is a measure of distance, which is always positive. Remember, when we started this section, we said what? Absolute value of 5 is 5, so is absolute value of negative 5 is 5. So the difference is, when you say absolute value of 5, you go on 5 units to the what? Right side of the 0. And when you say absolute value of negative 5, you go on what? 5 units to the left side of the 0. In either case, this is a measure of distance, so that's why the answer is what? Come up as positive number. So, can a positive number be equal to negative number? No. So, no solution. Okay, no solution. Okay, but what if it's equal to 0? Well, the only way this is going to happen is when x is equal to 5. So this is the only case you get one answer as opposed to 2. That's like when the right side is equal to 0. However, if the right side is negative, there is no solution. Why? Absolute value measures distance. What about this guy? Can absolute value of a number be less than or equal to a negative number? No. No solution. No solution, right? Because absolute value cannot be negative, right? Can absolute value of a number be less than 0? No. No solution. Can absolute value of a number be positive? Of course. But for which values of x this absolute value will be greater than 0? Turns out for all real numbers. Okay. No matter what you put for x, replace the x by, the minute you take what its absolute value, it's going to be greater than 0. Like what? Like, say, negative 6. Okay, that's greater than 0 because absolute value of negative 6 is 6. What about, let's just say there is an equal sign here. What about 0? Absolute value of 0 is 0. What about, well, there is no such thing as absolute value of 0 because 0 is a signless number. What about absolute value of 13? Yeah, it's positive, so all real numbers. Yes? What about this guy? Can absolute value of a number be greater than negative, regardless of what x is? Well, sure. So this would be all real numbers as well. All real numbers. Okay, no matter what you replace x by, whether it's 0 or a positive number or a negative number, the minute you take its absolute value, it's going to be positive, and a positive number is greater than a negative number. Finally, what if you got an equation and you got true absolute values? How would you solve that? So here is a formula. So here's a special case. Once again, special case. What if you got absolute value of x is equal to absolute value of y? How would you solve these kind of problems where you have absolute value on either side of the equal sign? Well, the procedure is very easy. What you do is you drop the bars just like before on both sides and attach plus or minus to the what? right side. So these are the solutions. You see it. Okay, so let's see if we can solve this guy. Absolute value of 2x minus 1 equals absolute value of x plus 3. Okay, so what is the procedure? Drop the bars on both sides, correct? But attach plus or minus to the right side. Remember, when you attach plus or minus to the right side, make sure you include x plus 3 inside the parentheses. Why? Because later on, we're going to distribute the minus by x plus 3. Okay, so this is two equations, what? In one, so either 2x minus 1 is equal to what? Positive x plus 3, or 2x minus 1 equals what? Negative what? X plus 3. So now try to solve these equations for x and box your answers. So the first guy is easy. 2x minus 1 is equal to x plus 3. So that will be x is equal to 4. Is that right? Here, before we solve isolate x, I need to distribute the negative. So I get 2x minus 1 equals negative x minus 3. Remember what a negative sign does in front of the parentheses? It changes everybody's sign inside the parentheses. Collect the x's to the left, so you get 3x. The numbers to the right, you get negative 2. You know, you add 1 to both sides, and then you add x to both sides. Okay, so x is equal to what? Negative 2/3. So the solutions are x is equal to 4, or x is equal to negative 2/3. Or you could just write this as 4 and negative 2/3, and the order doesn't matter, because these are what? Values of the same unknown, which happens to be x. And that's pretty much what 2.6 is all about. Thank you.